Hi everyone, in this video I will be talking about the problem 4 in homework 5. In this problem, the infinite impulse response filter is described by the difference equation. It is an all-pass filter because it is possible to show that the square of the impulse response amplitude is 1 for all omega. In part A, we want to determine the system function Hz. For this system, we are going to express Hz in two forms. So now you have the difference equation in time domain. It will be pretty straightforward to write down the difference equation in z domain like this. So then you can find the relationship between xz and yz. And finally, you can write down the transfer function hz like this. In part B, you want to show that the zero and the pole are reciprocals. So from part A, you know that the location of pole is 0.5 and the location of 0 is at 2. So since 1 over 0.5 is 2, so the 0 and the pole are reciprocals. In part C, we are going to show that the square of the transfer function magnitude is 1. So now, HEJ omega can be written like this. And the complex conjugate of HEJ omega can be written down like this, by changing the sign of the phase. So now, if you multiply H and its complex conjugate, you can get the value of 1. So we can show that the square of the transfer function amplitude is 1. And in part D, since we are able to prove that the magnitude response is 1 for all omega in part C, so only the phases will be changed while the magnitude remains the same. So we can write down the Ym like this by adding two different phases, phi1 and phi2. And in part D, we will be determining the values for the two phase terms, phi1 and phi2. In part D, we can use Python code to determine the bases as follows. First of all, you want to define a Hz transfer function, and then you can use the library cmath.phase to calculate phi1 and phi2. So then you can get phi1 and phi2. I hope this video helps you to solve the problem 4 in homework 5. Thanks for watching.